Hey virtual learners, Mrs. Steppa here. I am going to be doing a how-to video today on how to compare fractions using reasoning. That means you're thinking, not tricks that you're not going to remember because they don't make sense. So today's strategy, it's actually two strategies. I'm going to teach you guys how to use like numerators and like denominators to reason about which fraction is greater or less. So I am a math coach in Virginia. This is a 4th grade standard in Virginia. This is the aligning SOL. The students are expected in 4th grade to compare and order fractions and mixed numbers with and without models. I'm only focusing on using like numerators and like denominators today. There are other reasoning strategies I will make other videos for. And I don't do comparing and ordering usually together. I usually do compare with all my strategies first and then bring in ordering, but I'm going to show you both of those today with these strategies. Something important to remember is that when you're presenting students with fractions in 4th grade, all of the denominators should be 12 or less, and this is the aligning Virginia Beach objective. So first thing I recommend, in school we use a lot of fraction representations. This is an example of fraction tiles that we would use in school. Now on the other side of these tiles, they have the unit fraction. Unit fractions have a 1 in the numerator. It means it's one part of the whole. So this unit fraction is 1/3. So there's a 1/3 on the back of all three of these, and then students can understand 3/3 make the whole. That's why they're called thirds. But I prefer to use mine upside down because I want students to be able to look at all of these pieces and tell me what the pieces are called based off how many make one whole. So instead of telling them, hey, flip it over and tell me what piece is that, I would rather them say, well, there's 1, 2, 3 equal parts that make a whole, so those pieces must be thirds. Or there's 1, 2, 3, 4, 5 equal parts that make a whole, so those pieces must be called fifths. I also have another video on my channel that shows how you can create your own fraction bars using paper. Even if you don't have different color construction paper, you can do it with regular white paper and use crayons to label your different unit fractions, different colors. When I have students create their own fraction bars, I usually start with the whole, then I do halves next, and then I half the half to get fourths, I half the fourths to get eighths, and then I do thirds, sixths, and twelfths. I don't have my construction paper 12ths here. But those are great options for you to do and experience before you would start comparing and ordering fractions. There's quite a few prerequisite skills to understanding how to compare and order fractions using reasoning, so let's go over those real quick. I tried to think of all of them. I might not have them all. First thing we need students to understand before they even do this is that a fractional part always relates to one whole. So for example, if this is 1/2 of this whole, that doesn't mean that this is going to be 1/2 of every whole. So I usually have like a Hershey bar lesson where I do the king size Hershey bar and the fun size Hershey bar, and I have students do half of both of them, and they realize that halves are not always the same size. All fractional parts relate to the size of the whole. That's why it's very important whenever you're working with fractions to tell students up front, what does one whole look like? That's what we call defining the whole. All right, second prerequisite skill, we want students to understand how to name fractions with words. So not just writing the numbers, because sometimes they can just count and produce a fraction, but we want them to be able to actually say that fraction. So if it's 2 1/3 pieces, we want them to say 2/3. Or if it's 6 equal parts make the whole, we want them to be able to know that those parts are called sixths. Okay, that's very important, the language of fractions. Next, we want them to understand how many parts make one whole. So 4/4 is the same as one whole. 8/8 is the same as one whole. When your numerator and your denominator match, that means that you have as many parts as you need to make one whole. So if those numerators and denominators match, those are equivalent to one whole. Also, we want students to understand that the numerator, or the top part of the fraction, tells you how many parts you're considering, and the denominator tells how many parts make the whole. We want them to understand that a unit fraction is one piece of the whole. So for example, 1/4, 1/8, 1/10, those are unit fractions. 3/8, 3/10, those are non-unit fractions. And then after they understand that unit fraction, we want them to understand that all non-unit fractions are a sum of their unit fractions. Sum meaning I put those unit fractions together and that would together get me a non-unit fraction. So for example, 3 1/4, 1/4 plus 1/4 plus 1/4, if I get the sum of these, that's going to give me 3/4. But we want students to understand that 3/4 is the same as 3 1/4. The last prerequisite skill that I can think of off the top of my head, there might be more, is that we want students to be able to compare unit fractions and understand that the larger the denominator, the smaller the piece, and vice versa. In Virginia, this is a second grade standard. So if they have 1/4 and 1/3, we want them to know that 1/4 is actually less than 1/3, and that's tricky for them in the beginning because with whole numbers, 4 is greater than 3. But we want them to say, okay, well, 1/4, look at the size of the fourths and look at the size of the thirds. If I have one whole and I have to share it with 4 people, this is the size of a fourth. And if I have a whole and I have to share it with 3 people, each of those people is actually going to get a larger amount of the whole. So it's backwards from whole number thinking. We want them to have this understanding and be able to compare unit fractions before they're comparing any non-unit fractions. And we want them to understand that that denominator gives me an idea about the size of the pieces. They do need a lot of practice to start visualizing these pieces in their head. And the more they practice with the hands-on manipulatives, the less they will need to. They'll start putting these pictures in their head. All right, so let's get started. Okay, so here we go. We're going to talk about like numerators first. I have 2 examples, and then we'll do one where we're ordering using like numerators. So the cool thing to remember about like numerators is that if you have like numerators, that means that you have the same number of parts. I'm just going to build these 2 so you can see 3/4. So first I need to find my fourths, 4 equal parts. These are my fourths, and I need 3 of them. Okay, 3/4. Okay. And I'm going to do 3/8. So if I come over here and look for eighths, I'm looking for the one that has 8 parts that make the whole. 1, 2, 3, 4, 5, 6, 7, 8. And my numerator tells me I need 3 of those eighths. 3 of those eighths. So I'm going to bring 3/8 over here. All right, so now you can see I have 3 of each of these pieces. These are 3/4, these are 3/8. And remember, eighths are going to be smaller than fourths. Fourths are going to be larger than eighths because the less times I have to chop up that whole, the bigger my pieces are. So that means whichever one has bigger parts would be my greater fraction. So since fourths are bigger than eighths, I have the same number of pieces both times. I already know that 3/4 is going to be greater. I'm going to put a G for greater. And that means that 3/8 must be less. So then I can go ahead and put in my symbol, my greater than sign, and I can even write words. 3/4 is greater than 3/8. Practice that a few times with those manipulatives, and then they will be able to do it without the manipulatives. All right, let's take a look at 5/10 and 5/6. I'll show you this one without the manipulatives first, and then we can check with the manipulatives. So if a student is reasoning about this, it might sound something like this. Okay, so I have the same number of pieces. I have 5/10 and I have 5/6. So both times I have 5 pieces. So to figure out the greater fraction, I need to pick the one that would be the larger piece. I know that 1/6 is greater than 1/10. So then I know 5/6 is greater than 5/10. So I'm going to label and then I'll check with my blocks. Greater than, less than, which would mean greater than. I do my little. Okay, now let me check. 6 means 6 equal parts, right? And I need 5 of them. 1, 2, 3, 4, 5. There's my 5/6 and 5/10. Let's see, I believe those are the greens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, and I need 5 of them. And students will get to the point where they do not have to pull all 5 of them. They might just pull one of them and say, okay, well, this is a 10th and this is a 6th. So since I have 5 of both, I know that this is going to be greater because 6 are larger than 10ths. Okay? Alrighty. So was I correct? I can see with my manipulatives that I was correct. So I can write 5/10. When I'm reading them, I always read from left to right, is less than 5/6. All right, so now here on the bottom, I'm going to use this like numerator thinking to help me order up these fractions that all have a like numerator. Since they all have a like numerator, that means I have the same number of pieces, so I need to think about the sizes of the pieces. I'm looking for the smallest pieces first, since I'm starting with the fraction that has the least value. So I know tenths are smaller than 6th, 8ths, or 3rds, because if I take a whole and I have to chop it into 10 parts, those parts are going to be smaller than 6th, 8ths, or 3rds. So I know 2/10 would be the most least of those fractions. After I got rid of the tenths, my next least fraction would be 8ths, because 8ths are smaller than 6ths and 3rds. So I'll do 2/8 next. The next least would be 6ths, because 6ths are still less than 3rds. They're smaller than 3rds. So 2/6 is less than 2/3, which would mean 2/3 would be the greatest fraction here. So that is how you compare and order using like numerators. Let's try like denominators. All right, so when you are comparing like denominators, you'll notice that the part of the fraction on the bottom, that's the denominator, and we don't want to say the number on the top and the number on the bottom for numerator and denominator, because we don't want to create the misconception that a fraction is 2 numbers stacked on top of each other, because 2/6 is in fact a number. Every fraction is a number. So that's why it's important to use numerator and denominator instead of saying top number and bottom number. So I noticed that the denominators are both 6. So that means I'm comparing 6ths. That means I'm comparing the same size pieces. 6ths are the same as 6ths. When I come over here to my model, if I'm looking for 6, I'm looking for the one where 6 parts made the whole, right? So these are my 6ths here. And I need 2/6. That means 2 of the 6ths. Put them there. And I'm comparing that to 4/6. I'm going to check that out. 2/6 plus 4/6 is the same as a whole, isn't it? Because 6/6 is one whole, isn't it? Okay. All right. Now you can see I have the same size pieces. There's 6ths here and there's 6 here. So the greater fraction would just have more 6ths, right? So 4/6 is going to be greater than 2/6, right? So I'll put my G for greater on top of 4/6. And if 4/6 is greater, 2/6 must be less. That'll help me make my inequality sign. And then when I write my words, I want to read it from left to right. So I would say 2/6 is less than 4/6. All right, let's take a look at another example. This one is with tenths, but they're both tenths. They have the same or like denominators. That means since they're both tenths, they're both the same size pieces. Tenths mean that 10 parts make the whole, and I need 3/10 for my first fraction. And I need 8/10 for my second fraction. Or remember, it's 8 1/10. Okay, so I can see very clearly that since they're both tenths, whichever one I have more tenths of is going to be greater. So 8/10 is going to be greater than 3/10. I have more tenths, right? So greater, less. It can help me with my sign. I always think 2 is greater than 1. Don't do alligators in math class. We're not going to the zoo now. All right, and then when I write it with words, I have to read from left to right. So I will write 3/10 is, again, this one is another less than 8/10. A common misconception would be students would read this as 8/10 is greater than 3/10, which is not incorrect, but we want to remind them that when they're reading that inequality, we're going to read from left to right because that's the direction that we read. And I do notice that putting the G and the L on top of the fractions helps students when they're actually doing the words to go with that symbol. All right, so finally for ordering, remember all these fractions that I'm ordering have the same denominator. That means that they're all the same size pieces. Those pieces are eighths, which are those pink ones over there. So I'm going to do this one from greatest to least. Greatest would be the one that has the most eighths. So 7/8 would have to be the greatest. 8/8 would be 1 whole. 7/8 is almost 1 whole. After 7/8 is gone, the next greatest would be 5/8. Because 5 is more than 4 and 2. After 5/8, the next greatest would be 4/8, followed by the least of 2/8. So now those, like numerator fractions, have been ordered from greatest to least. So now you've seen how you can use reasoning, like numerator and like denominator, to compare and order fractions. The more students practice with this, the less they will rely on manipulatives or pictures because they're going to be able to use that reasoning. All right, thanks guys.